Hello everyone, myself Namrata Thakur, Senior Lecturer in the Department of Computer Engineering at Pravin Patil Polytechnic, Bhinder East. Today we are going to learn the third part of the third chapter, part 3, Process Management. I have already uploaded part 1 and part 2 video of the same. Kindly go through it to revise your concept about the process management. From this video, the student will able to understand what do you mean by thread, different type of threads, along with the concept of multi-threading and its different model. So let's start all the things in detail. What do you mean by thread? Thread is a part of process. So what do you mean by part of process? I am giving you one general example so that it will be more clear to you what do you mean by thread. If I am executing or if I am using MS Word, MS Word is one program. If I am executing it, it becomes a process. I am using the MS Word and at the same time I am using one part of MS Word for spelling checking, for font checking or for font changing and for inserting the image. That means in one process called as a MS Word, I am having three parts. First one is a spelling checking, second one is a font changing, and third one is inserting image. This each part is called as a thread. So my MS Word is having one thread for inserting the image, one thread for spelling checking, and one thread for the font checking. So these threads are part of the process. The thread is a part of process, or you can say that it's a lightweight process. It's not compulsory. One process is having only one thread. One process is having the multiple threads inside it. As you can see over here in this circle is a process which consists of multiple parts, and that multiple parts is called as a thread. There are two types of threading. First one is a single threaded system and second one is a multi-threaded system. Students, what do you mean by single threaded system? A single threaded system means a process which is having only one thread, and multi-threaded means one process consists of multiple threads. The example given by me of MS Word is a multi-threaded. Why? Because MS Word consists of multiple threads. One process, many threads. Now, we will see the difference between the process and thread. Are threads are required? Yes. Why? See the difference between processes and the thread. First of all, we will start with the definition of the same. Process is any program which is in execution, whereas thread is a part of process. Thread creation is very easy, but process creation is not that much easy over here. Process has its own address space. If I am saying that MS Word is storing or MS Word is loaded in the memory for the execution, at that time it is having its own address space. But suppose the thread called as a font changing, it will share the address space of the process. Now, process is called as a heavyweight process and thread is called as a lightweight process. IPC communication we have seen in the part 2, which is required for communication between the processes, and threads are directly communicating with each other. They don't require any kind of mechanism for the same. Processes are independent, but obvious thread is a part of process, therefore it will depend upon the process. One process contains the multiple thread, whereas we can't say like that multiple thread contains one process. This is the difference between process and the thread. Multi-threading system. What are the advantages of it? First one is a responsiveness. If one thread got failed, the another one is there to take the charge of it. So this is called as a responsiveness. Economy and the resource sharing are related with each other. As I said, thread shares the resources of the processes only. Therefore, there is no need to create the extra resources for the same. So it will result in the economy and the resource sharing, and it always support for the multiprocessor architecture. If multiple threads are there in one process, it will get executed in multiple processor. Therefore, it will support for the multiprocessor architecture. Let's see the types of thread. There are two types of thread. First one is a user level thread and second one is a kernel level thread. User level thread is also called as a ULT. As the name suggests, ULT, user level thread. The threads which are created by the user, or I can say that as shown in this diagram, the threads which are created at the user space is called as a user level thread. Students, you can easily see over there, these threads are created as a user space. There are two spaces, user space and the kernel space. But the threads which are created at the user space is called as a user level thread. User level thread, in this, all the thread management is done by the user only, like creation, deletion, or the management of the thread is done by the user only. Kernel is not interfering in the task of the user. So kernel doesn't know anything about the user level thread and the manages of the same. What are the different advantages of ULT? As I said, kernel is not going to interfere in the user level thread. Therefore, it are easy to create, simple to represent, and after that, it is implemented without the help of the kernel. Now, disadvantages is that no or less coordination among the threads and the kernel. If user is managing everything, there is no communication between the user thread and the kernel thread. And kernel is a controller of everything. Therefore, it is every time required to have the communication between thread and the kernel. If one thread causes page fault, it will block the entire process. Now we will see what you mean by kernel level thread. So kernel level thread is the thread which are created by the kernel. If user is creating, or the thread which are created at user space called as a user level thread, and if the threads are created at a kernel level, it is called as a kernel level thread. So created and supported by OS in the kernel space, all the thread management, that is thread creation, thread deletion, thread management like thread manipulation, communication, all these things are done by the kernel only. As you can see over here in this picture, here these are the kernel threads because these are the kernel threads because these are implemented at the kernel level. Now the next one is, what are the advantages and disadvantages of kernel level thread? First advantage is, since kernel is managing everything, therefore it is having kernel having full control on everything happens in the system. If one thread get fails, the kernel will schedule the another thread because kernel is a controller of everything. Kernel can take the decision of what to do in case of break, and it go or in case of block. It is good for the application that frequently block. Disadvantages: it is slow and inefficient, and it requires the thread control block to thread control block, so it is an overhead for the system. Now, the last part of this video is multi-threading. We have already seen this diagram in a previous session or in a previous slide. What exactly does it mean? Single-threaded system and multi-threaded system. Single-threaded means one process consists of only one thread. But in case of multi-threading, one process contains multiple threads inside it. So this is called as a multi-threaded. So multi-threading means ability of OS to support the execution of multiple threads within one process. So, if your system is supporting execution of multiple threads inside one process, it is called as a multi-threading. So, what are the advantages of multi-threading? But obvious, we have discussed in the previous slide like responsiveness, economy, resource sharing, and support for multiprocessor architecture. Is all about the advantages of multi-threading model. Multi-threading concept. Now, there are three models of multi-threading. First one is many to to one, and many to many. So, many to one, and many to many are multi-threading models. So, let's see in detail each and every model. First of all, we will talk about one-to-one model. Students here, keep in mind UK. You will get confused about the multi-threading model. Therefore, keep the mind the concept called as a UK. U stands for user level thread and K stands for kernel level thread. Now, in case of one-to-one model, here UK means what? One user level thread is connected to one kernel level thread. So, in one-to-one model, there is one-to-one relationship between kernel and user thread. That means one user thread is connected to one kernel thread. See here, as in this shown in the diagram, there are separate multiple threads are there, but one kernel thread is mapped to one user thread. Or you can say that one user thread is connected to one kernel thread. See here the connection between one to kernel and the user. One user connected to one kernel. So keep in mind UK one to one. Now, so multiple threads can run on the multiple processor. But problem with this model is creation of multiple kernel thread cause a overhead to the system. It's not easy to create a kernel thread every time. In case of one-to-one model, if suppose I'm having the 5 user thread, then I have to create a 5 kernel thread also. So it's very time consuming and headache to the system of the same. Now the next one is many to one. As I said, keep in mind UK. Many user threads are connected to one kernel thread. Many. First one is for U and second one is for K. So many user thread and one kernel thread. UK means what? First one U is related to many and one is related to the K. Therefore, many user threads are connected to one kernel thread. See in this diagram, you can easily come to know that there are 4 user threads which are attached to one kernel thread. So many kernel user threads get connected to one kernel thread. It's easy to create because only one kernel thread is there and multiple user threads are there. But the disadvantage is that if in case of kernel thread block or if it get fail, what will happen? The whole system will get collapse. So these are the biggest disadvantages of many to one model. Now next one is many to many. Again UK, many user threads are connected to many kernel threads. As you can see over here, 4 multiple threads are there and 4 kernel threads are there. So here multiple user threads are connected to the multiple kernel thread. So advantages is that if the user thread is blocked, we can schedule the other user thread to the other kernel thread because each are connected with each other. This system does not block if a particular thread is blocked because this one kernel is connected to all kernels. One user thread is connected to the all kernel thread. Therefore, if it is get blocked, all other things are there to take the charge. So many user threads are connected to the many kernel thread. These are all about multi-threading models. Thank you. If you have any doubt, let me know. I will surely help you to solve the same. Post your doubt in a comment box. Thank you.